All right, so we're in chapter 10 now. We're going to start in section 10.2. We're skipping the first section. And we're talking about what we call conic sections. And today we're going to talk about parabolas. Now the reason that we call a parabola and the shapes that we're going to talk about, conic sections. If you have a book, if you look in your book on page 707, they have a nice picture. The conic sections are all made by taking a cone, and a cone in 3 dimensions has 2 pieces. So a cone in 3 dimensions looks something like this. Not a perfect drawing of a cone. But if we slice the cone with a plane in different ways, we get the different conic sections. If we slice it flat, we get a circle. If we slice it at an angle, we get a parabola. If we slice it through both sides at an angle, we get an ellipse. And if we slice it so that it goes through the top and the bottom part of the cone, we get a hyperbola. So the reason we call these conic sections is they all come from slicing a cone in various ways. So today we're going to talk about parabolas. And we already know a little bit about parabolas. We've worked with graphing parabolas. We know what the equation looks like. But we're going to work with the definition of a parabola. Did I start this? I did. Okay. So we're starting with the definition of a parabola. A parabola, the way we define a parabola, is, and the book talks about, and when we talk about conic sections, they use a term called the locus. Locus just means a set of points. So parabola is a set of points that are equidistant from a line called the directrix. So they're equidistant from a line called the directrix and a point called the focus. And what the definition tells us is that we have, if we draw a quick sketch here, if this is our axis of our parabola, let me draw that a little better. So our parabola would look something like this. This blue line would be the directrix. And we'll draw the dot here. The blue dot is the focus. And our vertex is here. And the definition tells us that if we look at the distance from the directrix to the parabola, and this makes a 90-degree angle, D1, and I go from the parabola to the focus, d2, what the definition tells us is that d1, the distance from the directrix to the parabola, is the same as the distance from the parabola to the focus. And a parabola, we can, if we use the distance formula and write our distance formula for this line and this point to the parabola, we would come up with the equation for a parabola. The focus, what? And right, this is. It's not a random point. It's it's a specific point, such that if I find the distance from that point to the parabola, it's the same as the distance from the point on the parabola to the directrix. So every parabola will have a specific focus and a specific directrix. Just one. That's what makes it special, is that there's just one focus. For a certain equation of a parabola, there's just one focus and just one directrix. And we'll talk we'll work with some equations, and then at the end we'll talk about what the focus of the parabola, what's special about it in terms of something physical. So this is our definition of a parabola. The distance, equidistant from the directrix and the focus. The axis, it's important to remember the axis. The axis goes through the vertex and the focus. And is perpendicular to the directrix. So this makes the axis makes a 90-degree angle with the directrix. Yeah. No, because the axis, so this isn't the y-axis. This is the axis of the parabola. So the line that goes straight up the middle of the parabola, that's what the axis is. So if we have a shift, the axis shifts with the parabola. So the axis of the parabola always goes through the vertex and the focus and makes a 90-degree angle with the directrix. So what we want to do, the point of the lesson is to write our equation of a parabola using this definition. We know what a parabola looks like. Y equals x squared is a parabola. Anytime we have y equals something squared, we have the equation of a parabola. We know how to shift parabolas. We've worked with that a lot. Now we're going to work with a parabola with the idea of a focus and a directrix. We're going to find the focus and directrix. We're going to use the focus and directrix to find the equation. So let's look at a new form of our equation of a parabola. Oops, that's not what I want to do. So we know something about the vertex form of a parabola. We've worked with vertex form. We tested on vertex form. We converted to vertex form. We know for a parabola, vertex form is y equals a times x minus h squared plus k, where the vertex is the point hk. So we know that that's the vertex form of a parabola. That helps us find the vertex. The a tells us how stretched or compressed our parabola is. If a is positive, it opens up. If a is negative, it opens down. So we know all that about a parabola. Now we're going to use what we call the standard form for a parabola. And I'm going to give you two cases. One for a parabola opening up and down, and one for a parabola opening right or left. So first, let's talk about a vertical axis. So our parabola opening up and down. So standard form for a parabola with a vertical axis is x minus h squared equals 4p times y minus k. So notice when we have a vertical axis, x is squared. So anytime x is squared, you know you have a vertical axis, works, and anytime you have a vertical axis, you know that x is squared. Our vertex for this parabola, the vertex is at the point hk. The focus is at the point h k plus p. So p, this p out here in front of the y minus k, helps us find the distance from the vertex to the focus, and it also helps us find the distance to the directrix. The directrix for this parabola is going to be y equals k minus p. So I go from my vertex and I go p units from k and I get my focus, and I go negative p units from k to get my directrix. So I go up or down p units, and that gives me my vertex and my directrix for this parabola. The axis for this parabola is x equals h. If p is positive, so p greater than 0, our parabola opens up. If p is less than 0, if p is negative, the parabola opens down. And if our vertex is at 0, 0, our equation just becomes x squared equals 4py. So I'm going to draw a couple of quick sketches here. If this is, so we have a vertical axis. So if p is positive, my parabola opens up. The vertex is at hk. This is the directrix. Y equals k minus p. And the focus is up here at the point h k plus p. And the distance from the focus to the directrix is p units, and the distance, or I'm sorry, from the vertex to the directrix, and the distance from the focus to the vertex is p units. So I go p units up to get to the focus, and p units down to get to the directrix. And if p is less than 0, my directrix is going to be up here. My parabola goes this way. And my focus is going to be down here below the vertex. So if p is less than 0, I go p units down from the vertex to get to the focus, and p units up to get to the directrix. So p, the p in this equation, gives us the distance from the vertex to the focus and the distance from the vertex to the directrix. So that's why this p is important here. Questions on the standard form here? All right, let's go to a horizontal axis. Does everybody have this? Okay, so a horizontal axis. So for a horizontal axis, my form is y minus k squared equals 4p x minus h. So for a horizontal axis, y is squared. So anytime y is squared, you know you have a horizontal axis. Anytime you have a horizontal axis, you know your equation is going to be in this form with y squared. Our vertex is still at hk. Our focus, this time our focus moves horizontally. Since our axis is horizontal, our focus is going to be a horizontal movement away from the vertex. So we have to add p to h. Our focus is h plus p, k. Our directrix is going to be the line y equals k. I'm sorry, that's the axis. Our directrix is x equals h minus p. So we move horizontally p units from the vertex to get to the focus, and we move horizontally the opposite distance to get to the directrix. The axis is y equals k. If p is positive, p is greater than 0, our parabola opens right. And if p is less than 0, if p is negative, it opens left. So a quick drawing here of what we're talking about. This is my directrix. So if p is positive, my parabola opens right. The focus is over here. The vertex is at hk. And this is p units here. And the focus is at h plus p, k. And this is p units here. And the directrix is at x equals h minus p. So I move p units to get to the focus from the vertex, and I move p units to get to the directrix from the vertex. And if p is less than 0, my parabola just opens the other direction. So a couple of things from these drawings. The parabola is always between the directrix and the focus. the parabola opens away from the directrix. It opens around the focus. So our parabola is not going to cross our directrix. It opens away from the directrix, and it's between the focus and the directrix. And P, again, is the distance from the vertex to the focus and the vertex to the directrix. P is the distance along the axis from the vertex to the focus and from the vertex to the directrix. That's what the P in our equation tells us.
Vertex to focus.
Right, so we go P from the vertex, we go along the axis P units to get to the focus, and we go along the axis P units to get to the directrix. So P tells us how far it is from the vertex to the focus and the directrix. So all I want to do now is just do a couple of examples using this standard form with parabolas. Any questions before we move on? All right. So for our first example, we want the vertex the focus and the directrix of y equals 0.5 x squared. So first off, I see that x is squared. So that tells me right away that I have a vertical axis. And when we're looking for the vertex, when we're looking at the focus, when we're looking for the directrix, we need our equation. We need our equation in standard form. But let's figure out one other thing. Where's the vertex of this parabola? What's the vertex of this parabola? Are we subtracting anything from the x and the y? We're not subtracting anything. So our vertex is 0, 0. And for our, let me backtrack really quick. One thing I wanted to add, one thing to our horizontal axis. If the vertex is at 0, 0, our equation is y squared equals 4px. So if our vertex is at 0, 0, I just have the x, and I don't have anything subtracting from the y, and I don't have anything subtracting from the x.
There's nothing like that for the vertical though?
Yeah, we did that for the vertical as well, down here at the bottom. If the vertex is at 0, 0, our standard equation is x squared equals 4py. All right, so let's go back to our example. For our vertex at 0, 0, our standard equation is x squared equals 4py. So we want to write our equation in this form. So we want the x squared by itself, and we want everything in front of the y. So to get x squared by itself here, I'm going to divide both sides by 0.5. So I get y over 0.5 equals x squared. And y divided by 1/2 is the same as what? 2y. So I get 2y, and I'm going to change it around. X squared equals 2y. So that's our equation in standard form. I have the x squared by itself, and I have some number in front of y. So this tells us that 4p equals 2. This number in front of the y is 4p. So p is 1/2. Yeah.
Is it just coincidence that it's the same as the number that was in front of us in the original?
In this case it is, yes. It just turned out that way. So if I were to sketch, so p is positive. We know we have a vertical axis, and our vertex is at 0, 0. So p is positive. Our parabola opens up. So if I draw a quick sketch here, my parabola looks like so. My vertex is at 0, 0. We know it opens up. And our focus is on the axis, 1/2 unit up from the vertex. Yeah.
So where do you get that 0.5 from?
This 0.5?
No, the one down there.
I wanted our standard form is x squared equals 4py. So I want to rewrite this in standard form. So I wanted to get that 0.5 away from the x squared. So I just divided both sides by 0.5. So focus is 1/2 unit up from the vertex. Our focus is going to be up here. So the focus is at 0, 1/2. So I'm on the axis. I just move up 1/2 unit. And our directrix is 1/2 unit down. So our directrix is going to be down here, like so. And my equation for the directrix is y equals minus 1/2. And I could also use the equations that we wrote for our standard form, that the directrix is y equals k minus p. In this example, since our vertex is at 0, 0, k equals 0. And we said p is 1/2, so y equals minus 1/2. So we found our vertex, we found our focus, and we found our directrix. Questions on that one? All right, let's look at another one. We need to go back. Mm-hmm. Okay. All right, for this example, we want the standard form for parabola with the vertex at 0, 0, and the focus at 0, -2. So we want to write our standard form equation for this parabola. So what I suggest on these problems is make a quick little sketch. So here's my x and y axis. My vertex is at 0, 0. So my vertex is here. And my focus is at 0, -2. So my focus is down here. So which direction is this parabola going to open? down. My parabola is going to look something like this. The focus has to be inside the parabola. So I know that I have a vertical axis. So which coordinate is going to be squared, x or y? Let's go back to our, when we have a horizontal axis, y is squared. So when we have a vertical axis, x is squared. So we know that x is squared. And since it opens down, p is negative. We know that p is less than 0. How far is it from the vertex to the focus? How many units? Negative 2. So p is negative 2. We go negative 2 units from the focus to the, or from the vertex to the focus. So p is negative 2. Our vertex is 0, 0, so we know that our equation is going to look like x squared equals 4py. So we know, and we figured out, since it's two units down from the vertex to the focus, that p is negative 2. So x squared equals 4 times negative 2 times y. So x squared equals minus 8y is our standard form. And if it asks us for our directrix, we know that our directrix would have to be up here, 2 units above the focus. So this would be at y equals 2. Questions on that example? All right, last example for today. This example brings back one of our favorite topics. We want the vertex, focus, and the directrix of x squared minus 2x minus 16y minus 31 equals 0. So we have an x squared. So our x is squared, our y is not squared. So we know we have a parabola. So what this problem is telling us, to find the vertex, focus, and the directrix, we want to write in standard form. So we're going to write this in standard form. To write it in standard form, we want the x squared part on one side and we want the y part on the other. So I'm going to put the x parts on one side and the y parts on the other. So I'm going to say that x squared minus 2x equals 16y plus 31. Now, when we had a parabola and we wanted to write it in vertex form, what did we have to do? Do we remember? We had to complete the square. So we're going to complete the square on x. We're going to complete the square here. So we're going to complete the square here, so I get x squared minus 2x. And to complete the square, we did b over 2 squared. So negative 2 over 2 is 1. Squared is 1. So I'm going to add 1. And I'm going to add 1 to both sides to keep my equation the same. This is a perfect square now. This is x minus 1 squared. And this is 16y plus 32. I can factor out a 16, so I get x minus 1 squared equals 16 times y plus 2. And this is my standard form. This matches with my standard form for a parabola. My standard form is x minus h squared equals 4p y minus k. So now I have all my information that I need. The vertex. The vertex of this parabola is where? Right? So, and here h is, and remember we're minus here, so h would be 1 and k would be negative 2. So minus a negative 2 gives me a positive 2. My vertex is at 1, negative 2. 4p is 16. The number here in front of the y. So 4p is 16. So p equals 4. My axis is vertical or horizontal? Vertical, because x is squared. So my focus is 4 units up from the vertex. P is positive, so it opens up. And we could also just plug into our formula for our vertical axis. So the focus is, 4 units up from 1, negative 2 is 1, 2. And the directrix is y equals, and 4 units down from negative 2 is y equals negative 6. So when the problem gives us some messy equation and it's asking for these things, what it's asking us to do is write in standard form. And sometimes to write it in standard form, if we don't have it as x minus something, x plus something squared, we'll have to complete the square. All right, questions on that example? So these 3 examples are the main kinds of problems that you'll need to be able to do with parabolas. Now I said before the end that we'll talk about what the focus is for a parabola. Give a physical idea of what it is. For a parabola, if you have a mirror or an antenna or something that's in the shape of a parabola, anything, a light ray, a radio wave, television signal that comes in parallel to the axis reflects to the focus of a parabola. So if you have a telescope, the mirrors are parabolic, the starlight comes in parallel to the axis of the parabola and reflects to the focus. If you have a flashlight, you put the lens of a flashlight is parabolic, you put the bulb at the focus, the light goes out from the bulb, hits the reflector, and comes out from your flashlight parallel. So you have a nice tight beam in your flashlight. So that's the special property of the focus, is that light that comes in parallel to the axis reflects to the focus. Light that comes from the focus goes out and reflects parallel to the axis. Yes?
And no matter where it hits on the parabola.
As long as it's coming in parallel to the axis. So if your parabola is really huge, like if you've ever seen pictures of radio telescopes, they're like huge things in the ground, and then they have a thing like hanging right in the middle. That's the focus of that parabola. So anything that comes in parallel here, my light wave comes in, boom, is going to reflect to, yeah, that's a light wave. It went the atmosphere was a little disturbed here, so it bent around. We had a mirage there. And it reflects to the axis. And your flashlight, the bulb of your flashlight is at the focus of the parabola, and the light reflects from that lens and comes out parallel, so you have a nice tight beam in your flashlight. So that's one of the physical properties of a parabola, why the focus is
Good morning,
important.
everyone. Please pardon the interruption. Due to technical difficulties, the names of those who made the cut for the 360 crew for the 2012-13 school year will not be posted on the 360 page on the Monarch website until tomorrow. Thank you for your understanding.
So our homework, page 712, 1 through 10, and 13 through 53. Every other object. All right, there's your homework.